You are cruising down the interstate at 75 miles per hour. The radio is playing, the AC is blowing cold, and suddenly that little yellow wrench icon or the check engine light illuminates on your gauge cluster. If you are like the vast majority of drivers on the road today, your first instinct is to completely ignore it. You tell yourself the car is running fine, there is no smoke, and it is probably just a computer glitch that can wait until next month. That mindset is exactly how you turn a reliable daily driver into a catastrophic financial nightmare. Modern vehicles, whether you are driving a bulletproof Toyota Camry or a heavy-duty Ford F-150, have incredibly sophisticated electronic monitoring systems. They do not just count the miles you drive. The engine control module actively monitors the ambient temperature, the engine load, your idle hours in gridlock traffic, and your throttle habits to calculate the exact degradation of your engine oil. When that maintenance minder tells you it is time for a service, it is because the chemical shear stability of your fluid is completely destroyed. The oil has sheared down, losing its ability to maintain a hydrodynamic wedge between the metal components. Driving under these conditions is like running a marathon with sand in your shoes. You are slowly cooking the internal bearings in a bath of abrasive metallic sludge. And here is the brutal truth the dealership will not tell you until it is too late. Every single time you push past that warning light, the computer records the severe neglect in its permanent memory. When you finally go to trade that vehicle in, a technician simply plugs in an OBD2 scanner, pulls the hidden service history, and instantly drops the Kelley Blue Book value of your car by thousands of dollars. It is a completely avoidable disaster that starts with a simple light on the dashboard. Let us say you actually decide to do the right thing, save some money, and change the oil yourself in the driveway. You slide under the car with your drain pan, grab your wrench, and crack the main drain plug loose. The dark fluid starts trickling out. But you just made a massive mechanical mistake before you even lifted the vehicle off the ground. You forgot to pop the hood and remove the main oil filler cap located on top of the valve cover. When you leave that cap sealed tight during a drain, you create a powerful vacuum lock inside the crankcase. Think about putting your finger tightly over the top of a drinking straw and pulling it out of a glass of water. The liquid stays trapped inside the tube because no air can enter to displace it. The exact same fluid dynamics apply to your massive engine block. Because of that vacuum, the sludgy, contaminated oil drains incredibly slowly, and a significant volume of that filthy fluid remains trapped in the upper cylinder head, the variable valve timing galleys, and the complex hydraulic lifters. When you put the drain plug back in and pour 5 quarts of expensive, brand new synthetic oil into the engine, it immediately mixes with the abrasive leftover sludge. You have essentially ruined your fresh oil before you even turn the key in the ignition. Always remove the filler cap and pull the dipstick up an inch before you crawl under the car. It breaks the vacuum seal, allows the heavy metal particulates to flush out rapidly, and gives you total control over the flow rate so you do not splash hazardous waste all over your driveway. Before we get into the tiny split-second mistake people make during filter installation that will literally blow your engine apart on the highway, take a quick second to hit that subscribe button so you never miss out on these hardcore garage truths. Speaking of the oil filter, there is a tiny detail that separates a professional master technician from an amateur weekend warrior, and getting it wrong will cost you an entire engine block. You just bought a premium filter, you peel off the protective plastic film, and you reach up to thread it right onto the engine block completely dry. That is a massive operational error. The thick rubber O-ring seal on the base of that metal canister requires vital lubrication. When you thread a bone-dry rubber gasket against the scorching hot, dry aluminum mating surface of the engine block, the intense friction grabs the rubber material. As you torque the filter down by hand, the gasket aggressively bunches up, twists, and deforms completely out of its machined groove. It might feel securely tight to your hand, but you have just created a microscopic channel for highly pressurized fluid to escape. At first, it is just a slow weep that you will never notice dripping onto the plastic splash shield. But when you are merging onto the highway and the RPMs climb, the internal oil pressure spikes dramatically. That pinched, deformed seal blows out entirely, and your engine will pump out every single drop of oil onto the pavement in a matter of seconds. Your pistons will seize, and the engine will lock up before you can even safely pull over to the shoulder. The preventative fix takes literally 2 seconds of your time. Dip your fingertip into a bottle of fresh motor oil and smear a light, even coat all the way around that rubber gasket before installation. This simple step allows the filter to slide smoothly against the metal block, seating perfectly flat under pressure, and it prevents the rubber from heat baking onto the engine, which makes removing it during your next service 100 times easier. But honestly, lubricating the gasket does not mean a thing if you are threading absolute garbage onto your engine in the first place. You walk into the local auto parts store, look at the massive wall of options, and grab the absolute cheapest filter you can find, usually sitting in a flimsy, unbranded cardboard box. You justify it by thinking a filter is just a filter, and they all do the same job. You could not be more wrong about the engineering inside that metal can. Inside a cheap aftermarket filter, the pleated paper media is often held together by literal cardboard end caps and low-grade adhesive. When your engine gets up to full operating temperature, which is well over 200 degrees Fahrenheit, that cheap glue rapidly degrades. The cardboard structural caps collapse under the extreme hydraulic pressure of the oil pump, and the paper media rips wide open. Once that internal blowout happens, unfiltered oil, packed with abrasive carbon soot and razor-sharp microscopic metal shavings, bypasses the filter entirely and goes straight into your delicate engine bearings. Furthermore, modern engines require a very specific bypass valve pressure rating to operate safely. If you use a cheap, generic filter, the internal bypass spring is almost always too weak for the application. Every single time you accelerate hard, the valve pops open, allowing dirty oil to circulate freely. You are paying for a component that is essentially doing absolutely nothing to protect your investment. Always spend the extra $10 on an original equipment manufacturer filter, or a top-tier aftermarket option built with silicone anti-drainback valves and solid metal end caps. It is the only barrier protecting your engine's microscopic tolerances from total internal destruction. This brings us to the actual fluid you are pouring into the crankcase, and the massive deception the automotive industry pushes regarding ultra-thin zero-weight oils. You pop the hood, look at the plastic cap on the engine, and it explicitly says 0W20. So you blindly pour that water-thin oil in, assuming the factory engineers have your best interests in mind. But here is the brutal reality check. Engines do not live their lives in climate-controlled testing laboratories. That 0W20 recommendation is primarily engineered so the manufacturer can hit extremely strict government fuel economy mandates by reducing internal fluid drag. Sure, if you live in a freezing climate where winter temperatures routinely drop below 0 Fahrenheit, that ultra-thin oil is fantastic for protecting the engine during harsh morning cold starts. But if you live in a blistering hot region where the summer asphalt radiates at 120 degrees Fahrenheit and the ambient air is suffocating, that thin oil becomes a massive mechanical liability. Heat is the ultimate destroyer of oil viscosity. Under heavy driving loads, like sitting in gridlock traffic with the air conditioning blasting or hauling a heavy load up a steep grade, the internal oil temperature skyrockets. That 0W20 physically thins out way past its intended rating, breaking down the crucial protective film that separates your rapidly moving metal components. Your piston rings, camshaft lobes, and connecting rod bearings start making microscopic physical contact. This extreme heat thinning is exactly why mechanics in hot climates see a massive spike in oil consumption, excessive blowby, and premature timing chain stretch on cars running zero-weight oils. The fluid literally vaporizes right past the rings and burns up in the combustion chamber. In international markets where the ambient heat is absolutely brutal, those exact same engine platforms are filled with much thicker 5W30 or even 5W40 straight from the factory to maintain a robust, unbreakable protective barrier. If you are pushing your car hard in the sweltering heat, you need to understand that the manual's recommendation is a calculated compromise for maximum MPG, not the ultimate standard for long-term engine survival. We are about to cover a fluid mistake that will literally blow the main seals right out of your engine block and drain your bank account. But right before we get into that nightmare scenario, hit the subscribe button to keep your vehicle running stronger and out of the repair shop. So you are in the garage doing the oil change. You know you need robust protection for the summer heat, and you start pouring the fresh fluid into the engine. You check the capacity, and it says exactly 5 quarts. But you look at the bottle and figure, hey, if 5 quarts is good, dumping in 5.5 or 6 quarts must provide even better cooling and extra protection, right? That logic will absolutely destroy your engine from the inside out. Overfilling the crankcase is just as dangerous, if not significantly more dangerous, than running the engine severely low on oil. When you dump too much fluid into the oil pan, the resting level rises dangerously high, right up to the spinning counterweights of the crankshaft. At 3,000 or 4,000 RPM, that heavy steel crankshaft acts exactly like a giant industrial blender. It violently whips the resting oil into a frothy, aerated foam packed with tiny air bubbles. Mechanical oil pumps are designed specifically to compress and pump dense liquid, not aerated foam. When this frothy mixture gets sucked into the pickup tube, your engine suddenly starves for actual hydraulic pressure. The valve lifters start ticking loudly, the main bearings run completely dry, and the engine starts eating itself alive due to extreme friction. But the catastrophic damage does not stop there. The excess fluid drastically increases the internal crankcase pressure beyond what the engine was designed to handle. The positive crankcase ventilation system gets completely overwhelmed, sucking raw liquid oil directly into the intake manifold, choking the engine in thick white exhaust smoke, and permanently ruining your expensive catalytic converters. The immense internal pressure will also seek the absolute weakest point to escape, which means it will literally blow out your rear main seal, your front crank seal, or your valve cover gaskets. You just turned a simple $30 oil change into a massive $1,500 major engine repair. Always check the dipstick on perfectly level ground and keep the fluid precisely between the crosshatched minimum and maximum marks. When it comes to engine oil, more is never better. Finally, let us talk about the absolute snake oil sitting on the bright display shelves of every single auto parts store in the country. You know exactly the products I am talking about. The thick, gooey aftermarket oil additives in the flashy bottles that promise to miraculously restore lost horsepower, stop massive oil leaks, and make your high-mileage engine run like a brand new supercar. People pour these incredibly expensive bottles of thick syrup directly into their crankcase, thinking they are giving their tired engine a premium treat. In reality, you are playing a very dangerous game of amateur chemistry with a highly complex machine. Top-tier modern synthetic motor oils are meticulously blended by highly paid chemical engineers in massive laboratories. They contain a perfectly balanced, scientifically proven additive package of advanced detergents, dispersants, friction modifiers, and extreme pressure anti-wear agents. When you blindly dump a bottle of thick aftermarket additive into the mix, you completely ruin that delicate chemical balance. It is exactly like pouring cheap ketchup all over a perfectly cooked, expensive steak. Many of these heavily marketed additives drastically thicken the overall oil viscosity, putting immense, unnatural strain on the oil pump and actively starving the incredibly tight microscopic clearances in modern variable valve timing solenoids. Some of these aggressive additives contain heavy solvents that actually break down the host oil's protective film or cause the existing factory additives to physically fall out of suspension, leaving a thick layer of toxic sludge at the bottom of your oil pan. This is exactly why major automakers explicitly state in bold print in their technical manuals to never use these aftermarket products under any circumstances. No bottle of magic liquid can physically rebuild a worn-out piston ring or turn cheap, neglected oil into liquid gold. Save your money and put those funds toward high-quality, name-brand synthetic oil and a premium OEM filter instead. Maintaining your engine does not require an advanced degree in mechanical engineering, but it absolutely requires paying strict attention to the critical details that the quick lube places and dealerships completely ignore to save time. You have to treat the dashboard maintenance lights as a serious warning. Understand the vital physics of properly draining the system, refuse to use cheap cardboard filters, critically evaluate the right viscosity for your specific local climate, measure your fluid levels with absolute precision, and stay far away from expensive aftermarket gimmick additives. I want to know exactly what kind of mechanical battles are happening in your own garage right now. Drop down into the comments section and tell me what engine error codes you are currently fighting, what kind of weird ticking noises your vehicle is making on cold starts, or exactly what oil brand and viscosity you swear by for your daily driver. Let us diagnose these issues together in the comments. If you learned a new technique today that will save your engine and keep your car out of the scrapyard, smash that subscribe button, leave a massive like on the video, and I will see you in the next one.